Welcome to Make It Easy, everyone. In this video, I'm going to go over the chain rule. We need the chain rule because sometimes the other rules, for example, the power rule, do not enable us to solve all the problems. The problems with composite functions. For example, in this first case, we have an x squared plus 1 instead of x. And if we had just x, we knew according to the power rule or just the table that the derivative to it would be 1 over 2 radical x. Or some other times we're asked to find the derivative of a function with respect to a variable other than our independent variable. In the second case, we're asked to find the derivative of y with respect to z, but my independent variable here is x, not z, so we need to use the chain rule. So let's start with the first example. In this first case where we have a composite function versus x, what do we notice? We notice that we have a radical, right? Imagine we didn't have x squared plus 1 and we had only x. What rule would we use? We would use the power rule. So that is the first step we need to do. We need to recognize what is the outermost function, and the outermost function here is the radical. So I need to use the power rule. What I'm going to do is start rewriting this problem. Instead of a radical, I want to write it as an exponent. We know that radical is power of 1/2, so we'll rewrite it as x squared plus 1 to the power of 1/2. Then I'll start taking the derivative with respect to x because that's what I'm asked for. According to the power rule, I need to move the 1/2 right here as a constant coefficient, reduce 1 from the exponent, so 1/2 minus 1 with whatever I had. If I had x here, I would move it as x. I would leave everything as x right here. So I move everything down and I'll reduce 1 from the exponent. And lastly, because we had a composite function and we need to use the chain rule, I need to multiply it by the derivative of inside. And by inside, I mean everything except the exponent. Because in this case we had to use the power rule, the inside for us would have been everything except the exponent. So I need to multiply it by the derivative of inside according to the chain rule. And what is the derivative of x squared plus 1 with respect to x? It's 2x. Rewriting and simplifying, we get 1/2 times x squared plus 1 to the power of negative 1/2 times 2x. We can cancel the 2's, and because I have a negative exponent, we can move it to the denominator and write it as radical. So we have x divided by radical x squared plus 1. And this is the final answer to this problem. In the second example, we are asked to find the derivative of y, which is this function right here, x to the 40, with respect to variable z. But my variable here in the function is x. This is our independent variable. Because these two variables are not the same, we need the chain rule. So remember that. That's very important. And again, similar to the previous question, we want to recognize what is the outermost function. What rule do I need to use other than the chain rule? Because we already recognize that we need to use the chain rule, but that's the last step. So here, because we have a power again, we need to use the power rule. And according to the power rule, we move the 40 or the exponent in the front, reduce 1 from the exponent with whatever we had. So if we had a happy face instead of this x, we would write it as happy face to the power of 40 minus 1. So whatever you have except the exponent, you would move it and reduce 1 from the exponent. And then lastly, because of the chain rule, we need to take the derivative of inside. Again, inside in this case is everything except the exponent, just like the previous question, with respect to z. And what is the derivative of x with respect to z? We don't really have any information about how the rate of x is changing as z changes, so we leave it as is. So this is going to be the derivative of x with respect to z. So the final answer to this question is 40 times x to the power of 39 times dx over dz. Let me know if you guys have any questions in the comment sections below.